Hey everybody, Morgan here. So now we're looking at page 15 of the lecture outline. And this page is the one that's going to help you with that big homework that I set you with 36 different structures to look at. So for each of these molecules, we're going to look at a Lewis structure. And from that, we're going to try and figure out the number of sigma bonds, the number of pi bonds, number of unshared pairs on that central atom, etc., etc. Okay? We'll look for the hybridization on that central atom. Okay? Determine the geometry of the atom and the lone pairs, which the AP exam calls electron domains. And we're going to ask if the molecule has a dipole moment or any unusual features. Now let's start off with a really straightforward one, which is methane, which has carbon at the center. Very simple, straightforward structure. Carbon's the central atom. Now there's one bond here, one bond here, one bond here, one bond here. They're all sigma bonds. 4 sigma bonds. Remember, sigma bonds are the single bonds. Now, what's the hybridization on this central atom? Well, there are 4 things attached to it, which makes it an sp3 hybridization. Okay? The shape for something like this is going to be tetrahedral. It's a pretty straightforward molecule. Now we'll look at ClF3. Chlorine in the middle. Now 3 fluorines, I'm going to start off with those because they form only single bonds. Now, the chlorine has 7 valence electrons. So 1 here, 1 here, 1 here to complete the bonding. That leaves us 4, so that's 2 lone pairs. And maybe we circle them just to make them a little more visible. So chlorine is the central atom. It has 3 single bonds, so that's 3 sigma bonds. Now, there are also 2 lone pairs on this. Okay, we have to realize that. So the shape, when you have 3 atoms and 2 lone pairs attached, will be T-shaped. 2 lone pairs. Now, this is going to be an atom that has a dipole moment. It does not have equal distribution of its electrons. It's polar, dipole moment. As opposed to this, which is a pretty dull and boring molecule, actually. Okay. Now, the hybridization over here, I have 5 things attached, which makes that an sp3 D2 hybrid. Okay. Now water. Oxygen. It's got its 2 lone pairs and bonds to 2 hydrogens. I know that Lewis structure. Oxygen's in the middle. 2 sigma bonds, 2 lone pairs. 1, 2, 3, 4 electron domains. That makes it sp3. We know it's bent, or some people say angular. And man, it has got a major dipole moment. Okay? Pi5. I'm going to do line structures from here on out, folks. Getting a little lazy today, sorry. And there will be 3 lone pairs on each of these iodines. So phosphorus is in the middle, and I'm counting 5 sigma bonds. I don't see any lone pairs on the central atom. Remember, we're asking about lone pairs on the central atom. Unshared pairs on the central atom. Okay? 5 things attached makes this sp3d2, just like the one up above it. Okay? Except the shape this time is triangular bipyramidal, not T-shaped. It's nonpolar. It is a perfectly symmetric molecule, so all the individual dipoles cancel out. Now this sulfur has 6 fluorines attached to it. Fluorines all have their lone pairs. Sulfur in the middle. There's 6 bonds, so we'll call it 6 sigma bonds. Okay. No lone pairs on the central atom. 0 lone pairs. Okay. With 6 things attached, that's sp3d2, and the shape is octahedral. And there's no interesting features really here, okay, except maybe you might want to say it sees more than an octet, but it doesn't have a dipole moment or anything like that. Now, we did the structure for triiodide previously. 2 lone pairs on the central iodine. So there's an iodine in the middle. It's sp3d because 2 atoms and 3 lone pairs are 5 things attached. It has 2 sigma bonds. It has 3 lone pairs. Okay, it's linear and nonpolar. Okay. Unusual features may be that the iodine is seen more than 8. Some people might want to list that. Now BH3, favorite molecule for talking about on tests. Boron is in the center. 3 sigma bonds, 0 lone pairs. Okay. It's sp2. It's trigonal. Okay. I-NaL or O-NaL. I've seen it spelled both ways. Okay. Now, it definitely has an unusual feature that the boron is less than 8. Okay. It's not a full octet. Nonpolar, though. It's perfectly symmetric. SF4, sulfur. Fluorines. We did this one actually in the lecture outline also. Lone pair on the sulfur. So sulfur's in the middle. Okay. It has 4 sigma bonds and 1 lone pair. It's an sp3d. Okay. The shape is seesaw. Okay. And it's polar. It has a dipole moment. That is a polar molecule. Now NO2 minus, double bond to an O, lone pair. Okay. Typically we'd put brackets around it, O minus sign. So nitrogen there is in the middle. It's sp2, 3 electron domains. That one, and the lone pair. Okay, it's got 1 lone pair. Right? It's got 2 sigma bonds. But it also has 1 pi bond. The sigma and the second bond there is a pi bond. Okay? It's got a dipole because it's bent. And it has another unusual feature that's really worth mentioning. Resonance. And we actually use that as our example in the lecture outline for resonance. BeCl2 looks like that. Be in the middle. Okay. It's got 2 sigma bonds, 0 lone pairs. It's linear. sp hybridized. Okay. It doesn't have a dipole moment. Doesn't have resonance or anything like that. But you might want to mention that it has only 4 valence electrons. There's no lone pairs there. So that beryllium, it's pretty reactive. Okay? And it's nonpolar, no dipole. Okay. All right. And that is page number 15 from your lecture outline. Thanks for tuning in. This is Morgan signing off.